Going on the Test 11 study guide, the formula for chromium chloride is CrCl3. So for the remainder of the problem, anytime we see chromium chloride, that's going to be CrCl3. It tells us the chromium, which is Cr, weighed 832 grams. And how much did the chromium chloride weigh? All right, so when you look at these problems, they're ratio problems at heart. You have to get the pieces correctly figured out here. So our chemicals involved, our elements involved, we have chromium, Cr, we have chlorine, Cl, we have chromium chloride, which is CrCl3. We want molecular weight to go in one column. Molecular weight comes from how much each atom weighs in addition to how many of each we have. So if we look at the original formula here, Cr with no subscript implies there's one chromium in every molecule. Every chromium weighs 52, so the total molecular weight in a molecule of chromium is 52. Every chlorine weighs 35, and the formula says we have 3 of them, so we do 3 times 35. That gets me 105 for the weight of the chlorine. 52 and 105 make 157 for the weight of the molecule of chromium chloride. Then we have actual numbers, and the information telling us the chromium, which is Cr, this, weighed 832 grams. So 832 goes in the actual column under chromium. How much does the chromium chloride weigh? They're asking me to find this number, so chlorine is no longer necessary. I needed that 105 to get the 157, but at this point, all they're asking me for is that information. That's what I needed to do. So we take 52 over 157 is equal to 832 over x. If I cross multiply 52x on this side, on the other side I have to do 832 times 157. Be a good time for a calculator. Maybe. There we go. 832 times 157 comes out to 130,624. That's for that product. Divide both sides by 52. We get whatever we get. In this case, we get 2,512. Verify that the numbers match, and that's that problem. So on the test, you should expect a chemical formula of that variety. That chart will help you get the answer correct, and then again, once you get everything properly lined up, you should get a nice, friendly answer like that. Number 2, shoes cost $20 per pair, booze cost $60 per pair. Arlene and Jerry spent $3,200 and bought 3 times as many boots as shoes. So what we have are boots and shoes. Let's focus on that first. We don't know about shoes and boots, so they have to tell us how much they cost. So that helps us establish value. First thing I would do, since I can see it's a value-related problem, is I'm going to put my categories of shoes and boots here. And I want to figure out number of things using variables to represent those things. So S for shoes, B for boots. And then I want a value. And value we can see is given in dollars per pair, so value is given in dollars. And every pair of shoes costs $20. We bought S of them, so 20 times S is how much value the boots is, or shoes are. And then each pair of boots is $60. We bought B of them, so 60 times B represents the value of all the boots we bought. Then if we take a look at the information they give us, the specific information, they spent $3,200. Okay, so what they spent represents value. The value of what they spent in dollars, the value of what these are worth in dollars, tells me that one equation is going to be, just using these variables, 20s plus 60b is equal to 3,200. You may or may not notice, but 20, 60, and 3,200 all divide by at least 10. But since it's even, and then the second digit even there, everything divides by 20. So if I do that, I'm going to get S plus 3b is equal to 160. Anytime you can get equations smaller in size, it's worth doing, so I would do that. The other thing is what tends to mess up people on this specific problem. It says they bought 3 times as many boots as shoes. And the most common mistake people want to do is like 3B equals S. That's what they want to do, because 3 times boots equals shoes. But the thing that messes this up, it says 3 times as many boots. All right, so if we turn off math for a second and just think about the meaning of that sentence, and ask yourself, what did they buy more of? Obviously, if they bought 3 times as many boots, they bought more boots. So if I start off with B is equal to S, which is a false statement, I know they bought more boots, so this number is bigger than this number, 3 times bigger specifically. So if this number is 3 times bigger than that number, we take the smaller number times 3 to make the bigger number. So be careful with times as many. These specific words here, times as many, it messes people up all day long. So be careful that you understand what's bigger. The bigger number equals the times the smaller number. When you don't know what they are numerically, you can determine based on the words what's bigger. So B equals 3S would be my other equation. So at this point, as far as solving this equation is concerned, substitution works very nicely. B and 3S are equivalent, so change this B into a 3S. So I'm going to get S plus 3 times 3S equals 160. That gets me 9 plus 1, so a total of 10S on the left equals 160. Divided by 10, I get S equals 16. How many pairs of each did they buy? So obviously, bought 16 pairs of shoes. If I take B equals 3 times S, that gets me 48 pairs of boots. So 48 pairs of boots. And 16 pairs of shoes. These are easily checked if we want to verify. 2 things are supposed to be true. We're supposed to have 3 times as many boots as shoes, which we can see 48 is 3 times as many as 16. The other fact is we're supposed to have spent $3,200, so we take 48 times 60, which is how much boots are worth, plus 16 times 20, that's how much shoes are worth, and that comes out to $3,200, the total amount of money spent. That verifies that our answer is correct. Number 3. Amy had a 200-mile head start on Kathy. So the initial setup here is Kathy is here, Amy is here, and Amy is 200 miles ahead of Kathy. All right. Kathy drove 25 miles an hour, Amy ran at 5 miles an hour. How far did Kathy have to drive to catch Amy? Something that's clearly missing in this problem is anything about time. And that implies they left at the same time, and if Kathy caught Amy, that means they entered at the same time. So Amy is running away from Kathy, and she goes some distance that we don't know. Kathy is driving towards Amy. She's going some distance. We also don't know that distance. Altogether, Kathy went 200 plus Amy's distance. So d sub A plus 200 is equal to d sub K. All right, so I make my picture. Again, I've got my head start for Amy. She's going away. She's running as fast as she can. Apparently 5 miles an hour for a long, long time probably. Kathy's got to catch up to her. She's going 25 miles an hour. She wants to catch her, but maybe not that much if she's only going 25. But anyway, that's the distance relationship. Job 2. Kathy and Amy are the categories. And we care about rate and time of both of them to determine distance expressions. So, Kathy is driving 25 miles per hour. Amy is running 5 miles per hour. Again, they tell me nothing about time. That implies that times are equal but unknown. So Kathy's total distance is 25t, whereas Amy's total distance is 5t. And once I get these distances, this is d sub k, because it's in the Kathy row under distance. This is d sub a, because it's in the Amy row under distance. I come back over here, put those things in. Amy's distance 5t plus 200 equals Kathy's distance 25t. We simply solve for t now. That gets me 200 is equal to 20t, which means t is equal to 10 hours. Now, if the question says, how long did Kathy have to drive to catch Amy, or how long did Amy run, that's what that's answering. This is how long, how much time has passed. So they both went for 10 hours. Kathy drove for 10 hours, Amy ran for 10 hours. But the question doesn't say how long, it says, how far did Kathy have to drive? How far is distance? So the question is, how far did Kathy have to drive? So we're looking for Kathy's distance, so we have to do 25 times 10 is equal to 250 miles. If the question had asked how far did Amy run, it would have been 5 times 10, 50 miles. So her 50 miles plus the 200-mile head start gets Kathy's 250 miles. You can see by that picture very clearly that's what happens. But again, I see too many people getting to here and stopping because they got an equation solved. Answer the question every time. That's what I'm looking for a final answer on this. Number 4 and 5 both are going to be abstract equations. This one says find A. Before I even care about this, I care about no fractions. So I'm going to take my equation, multiply by AY. The common denominator of the only fractions in the problem. Z is not a fraction. AY times x over y makes AX. We multiply first by dividing, so the y's cancel, then multiply the results, A times x. Do this multiplication, AY times Z, there's no fractions, I get AYZ. And when I do this multiplication, A cancels A, leave me with MY. Always start there, get rid of all the fractions. Job 2, it says find A. At this point it matters because I got all the fractions gone on. There's no parentheses, no fractions, ready to go. Whatever says find, I want to make sure everything containing that letter is on one side, everything not on the other. This has A, this doesn't. Both of these things are on the left, that's on the right, it's ready to go. So, once I get everything separated, which is already there, I simply take out my common factor, which is going to be whatever this is. It's always my common factor. And then whatever's left over, if I take A out, I'm going to be left with X. Take A out of this, I'm left with YZ. Nothing happens to the side not containing the letter. And then if A times X plus YZ equals MY, anytime I have what I'm looking for times something equals something, I divide by the something being multiplied by what I'm looking for. So divide by X plus YZ here, divide by X plus YZ here. Those cancel, leaving me with A equals, and MY over X plus YZ is the answer. Number 5, same idea, pretty much the same difficulty. X over y minus z equals m over k. Common factor, or the least common denominator here of k and y is ky. Multiply ky times x over z. The y's canceling with kx. Ky times minus z, that's not a fraction, so I just get minus kyz. And ky times m over k, the k's canceling with my. Kx minus kyz equals my. So once again, once the fractions are gone, there's no parentheses. Now what I'm finding is important. K is what I'm finding. Once again, k's here, my is there. These have k, that doesn't. Let's say it said find y, then I'd probably move the kyz over there so all my y stuff's together. So again, whatever you're trying to find establishes what you have to do in this step. Rearrangement if necessary, but again, these both have k, this doesn't. They're on separate sides of the equal sign. You're ready to go. The step about rearranging has been dealt with. Common factor of k comes out. Again, the common factor is always this guy. And then x minus yz is left over if I take k out. And just like the last problem, k times this. I don't want the times that part, so divide by x minus yz on this side. Divide by x minus yz on that side. That cancels that, leaving k. And my over x minus yz is the end result. Number 6, expand. Now I'm going to do this 2 ways. Those of you who've been doing Pascal's triangle and getting it right, I do it that way. If you haven't been getting right with Pascal's triangle, I'm going to do it the second way. So Pascal's triangle first, we got 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. The power is 3. This has 4 objects in it, so this is the row we want to use. And we take the Pascal number, the first object to the highest power, which is 3, the second object, which is -2, to the lowest power, which is 0. So the first term is created by the Pascal number, whatever this is raised to that power, and whatever this is, including the sign, raised to the 0 power. Then you just work this power down, work this power up, and make the number change for Pascal. So the next idea is going to be 3. Then we're going to have x to the second, we're going to have -2 to the first. The next object is going to be 3. And then we have x to the first, -2 to the second. And the final object is going to have a 1, x to the 0, -2 cubed. Okay? The negative in there makes negative signs happen on some of the terms, but not all the terms. So when you get an even power, the 0 power makes a +1. So +1, and x cubed makes x cubed. Even an odd power makes a negative answer, so negative 2 times 3 is negative 6x squared. Even power positive, 4 times 3 is 12x. Odd power negative, negative 8 times 1 is negative 8. And that is the end result. That's x minus 2 expanded completely using Pascal's triangle. And again, that works very efficiently. If you've been getting them right and doing it that way, more power to you. I would keep it up. If you've been getting it wrong that way, the other technique that would be workable on this, get some room over here. Shrink that up, shrink that up. Oops. All right. So x minus 2 cubed means x minus 2 times x minus 2 times x minus 2. If we focus on these two x minus 2's first, that's going to be x times x is x squared. Then we have the outside and inside products, negative 2x and negative 2x makes negative 4x. Then we have the last, negative 2 times negative 2 is positive 4. So then we have x squared minus 4x plus 4 times x minus 2. Then, if I just do the distributive property, x times all this, x times x squared is x cubed, x times negative 4x is negative 4x squared, x times plus 4 is plus 4x. Then I do negative 2 times each of those, and be careful, it is a negative 2. Negative 2 times x squared is negative 2x squared. Negative 2 times negative 4x is positive 8x. Negative 2 times positive 4 is negative 8. Lined up like terms, if I add straight down like terms, x cubed plus nothing. Negative 4, negative 2, add to make negative 6x squared. Positive 4, positive 8, add to make positive 12x. Then minus 8 has no like terms. Get the same result regardless of how you do it. Pick which technique you're better at. Go with it for the test. If you like this way better, just know that this is much more efficient as the power starts getting bigger. If it's third power, this is about the same. If this was a 10th power, this would take over a page. This is going to take about maybe an extra line because it's going to be too long. You have to go to the next line down to get that. But just keep that in mind that Pascal's triangle is the more efficient way. But if you're not getting that right currently, this would be better suited for you for now to get it right for the test, and then be working on that to get better at it. Number 7, solve. Some of you aren't solving. It says solve 9x squared minus 64 equals 0. I'm noticing the structure of this. I see there's no x to the first power term, so the legal way to do this, that would be the easiest, would just be to move the constant to the other side. So x on one side, number on the other side. Divide both sides by 9 to get rid of that coefficient. That leaves me x squared equals 64 ninths. And then I got to square root both sides. And the rule of square roots is this. If I invent the square root symbol, in other words, it wasn't part of the problem to begin with, I put it on myself, I have to put a plus or minus in front of this. So if x squared is equal to 64 ninths, then x equals the plus or minus square root of 64 ninths, and that just means to square root the top and bottom individually. So 8/3 plus or minus 8/3 would be the right answers. The other option here would be factoring. If we look at 9x squared minus 64 equals 0, and I look at this as a difference of two squares, 3x times 3x makes 9x squared. Positive 8 times negative 8 makes negative 64. And if I have a sum and difference of the same two objects, negative 24x plus 24x cancels, leaving us with no x terms. So that's the difference of squares factored form. If you go this route, just know I'm not done yet. I'm looking for answers to say x equals numbers. This just factored form equals 0. So I have to take factor number 1, 3x plus 8, set it equal to 0. Move the 8 over, 3x equals negative 8, divide by 3, you get x equals negative 8/3. Factor 2, 3x minus 8 equals 0. Move the 8 to the other side, change the sign. 3x is equal to 8, divide both sides by 3. X equals 8/3. So you can see positive and negative 8/3 also for this one. If there is no x to the first power, both techniques work every single time. For the sake of this test, if it's not factorable, this will still give you an answer as a radical where this wouldn't factor, so it would be kind of tough to do. So that works every time, no matter how ugly the answer is. This only works when you got nice, pretty perfect squares. It'll be that way on the test, though. So take your pick on these for the sake of this test. Number 8, same deal, solve. It's a polynomial function. I see x to the third, x to the second, x to the first. I like descending order equal to 0. I like the highest power positive. So I'm going to get the 14x moved over to the left. X cubed is positive, x cubed plus 5x squared. I don't care about that one. Minus 14x, I don't really care about that one either. As long as the highest power term is positive, it's in good shape. So that's my first task, is to get everything on one side equal to 0, highest power term positive, so moving to make that occur. Then, look for a common factor. X to the first power is the lowest power that's shared, so x to the first power taken out leaves me with x squared plus 5x minus 14. At this point, this no longer has an x, so x is no longer common, so that's why 1x was able to come out, nothing bigger than that was able to come out. I also have to consider that this is a quadratic trinomial, so probably it factors again. So we're looking for the two numbers that multiply to make negative 14, that also add to make positive 5. If we think it through, we're going to get positive 7 and negative 2 do the trick. If we multiply, 7 times negative 2 makes negative 14. 7 plus negative 2 makes the positive 5. And of course, we're going to have x times x makes the x squared. So if you just imagine FOIL, x times x makes x squared. Negative 2x plus 7x makes 5x. 7 times negative 2 makes negative 14. And again, some of you get there and stop. You're like, I've done a lot of stuff here, so it must be done, obviously, because it's a lot of work. But solve means x equals, and this doesn't say x equals. It says a factored form equals. So the last step in this process is factor 1 and factor 2 and factor 3 ought to all be set equal to 0. The way multiplication works, if this equals 0, I'm multiplying 0 times stuff, I get 0. If this equals 0, I'm getting 0 times stuff, which equals 0. If that equals 0, I get 0 times stuff equals 0. So I've got 3 different factors here, each one containing x, so each one creates an answer. So x equals 0, x plus 7 equals 0, and x minus 2 equals 0. Each one of these represents a valid solution to the problem. This one's already done, x equals. This one I need to move the 7 over, so x equals negative 7. This one I need to move the 2 over. I get x equals positive 2. So altogether I get x equals 0, negative 7, positive 2. That's the type of solution you're looking for an answer for that type of problem. And be careful, you go all the way to the end on the solved problems. Give me number answers for each of these. Number 9, simplify. And we have a division of polynomials problem. I see some cubic functions in there, x cubed, x squared, x cubed, x squared, x. I've got a division, so I've got to flip this one over. What I would probably do to begin with is I would take this thing and this thing, take the common factor of x out of both of those as I flip that second fraction over. So my first step on my paper would look like this. X parentheses, and I'm going to rearrange the order as I do it. X cubed divided by x makes x squared in front. Negative 7x squared divided by x is negative 7x in the middle. 12x divided by x is plus 12 on the end. That's still over x squared minus 9x plus 20. I'm going to change the division to a multiplication. Then my second fraction, I'm going to put this red stuff on the bottom because I'm dividing this. I need to change the multiplication. This fraction reciprocates. And again, common factor of x happening here. So x parentheses, x squared minus 8x plus 12. And then I'm putting the x squared minus 11x plus 30 on top. So that's my first step. I go ahead and take out my common factors as I rearrange this division, change to multiplication, make it into a much friendlier problem. The remaining part of this is I've got a quadratic here, 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 and here, so I need to factor each quadratic expression. So I'm going to go ahead and do that next. So I got this times this. So x is already out. 12 will be negative 3 and negative 4, which multiply to make 12. They add to make negative 7. So x minus 3, x minus 4 goes on this one. On the bottom here, x squared minus 9x minus 20, negative 4 and negative 5, negative 4 plus negative 5, so x minus 4, x minus 5. Then up here on top, positive 30, negative 11, that would be negative 5 and negative 6. Two negatives multiply to make a positive, negative 5, negative 6 make negative 11, so x minus 5, x minus 6. And finally the red one here, negative 2 and negative 6 multiply to make positive 12, they add to make negative 8, so x is already out, x minus 2, x minus 6. Once you get everything factored, anything on top that matches anything on the bottom cancels. So this x matches this x. X minus 6 matches x minus 6. X minus 5 matches x minus 5. X minus 4 matches x minus 4. What's left over is on top, we have an x minus 3 left over. On the bottom, we have an x minus 2 left over. For the sake of this test, expect that to happen. Everything but one thing on top and bottom cancel, so you should be left with something looking like that. If you don't get that situation, you probably factored something improperly or forgot to flip something. Like if you don't flip that over, then you're going to have some things not canceling, specifically the x minus 5s and the x's. So be careful that you do everything you're supposed to do there. Factor completely. Look for the common factors. Once the common factor's out, everything quadratic. Number 10, simplify. And this is probably one of the easier problems on the test. We have term 1, term 2, term 3, and term 4 within this fraction. And the black and the red and the blue are all fractions inside the fractions. The 3 is behaving itself. I want to create the exact same structure, so I'm going to create the same structure, something over like this. So something plus something on top, something minus something on the bottom. You might even want to start there, but I want no fractions here, 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 or here. So I'm going to multiply by the least common denominator of these fractions, which I'm looking at x and y and x and y. Those are the only denominator pieces. And the highest power of x is 2, the highest power of y is 2. So x squared, y squared is the magic multiplier here. So x squared, y squared times that one, x squared, y squared times that one, x squared, y squared times that one, and x squared, y squared times that one. For the black times the purple here, x squared, y squared times 5x squared over y squared. Every one of these purple things is a numerator object. So this is on top, this is on bottom. They cancel. 5x squared times x squared is 5x to the 4th. And of course a plus sign. Next one, the red, we have x squared, y squared, numerator object times 2 over x squared, the x squared in the denominator. That cancels that, leaves us with 2y squared. For the green one, there is no fraction, so there's no cancellation. I simply multiply 3 times x squared times y squared. All I can do is stick them together. So that's all that happens to the green one. Then the blue one, numerator object x squared, y squared times denominator object x squared, y squared, x squareds and y squareds both cancel, leave me with only minus 4. You're done when all the fractions disappear. So you're going to have a fraction as an answer, but each one of these objects is not a fraction. And again, I see people put the wrong sign here. I count it wrong if you do that, so be careful that you don't. Just pay attention to detail in that problem. Number 11, simplify. We have scientific notation, sort of. So the first thing I would do, seeing this scientific notation structure, is I'd make better scientific notation. So 5,000, I want to become 5. I made this 3 decimal places smaller, so I have to make that 3 bigger. So 24. Second thing, I want this to be 6. I made that 1, 2, 3, 4 decimal places bigger, so I have to make that 4 smaller. Negative 42 minus 4 is negative 46. Be careful, smaller means subtract. If you subtract from a negative, you actually add the numbers. This was plus 3, 21 plus 3, both positive. Add to make a positive 24. On the bottom here, I've got 15,000. I want that to be 1.5. All right, so 1.5, and that's 1, 2, 3, 4 decimal places smaller, so I have to make this 4 bigger, which is plus 4. But again, pay attention to what's happening. Negative plus positive actually subtract the values, so negative 28 is what I get out of that. Next, I'm going to multiply the stuff on top together. So I'm going to multiply 5 times 6, which gets me 30. And I'm going to multiply the powers of 10 by adding the powers of 10. 24 plus negative 46 makes negative 22. If you write it out here, 24 plus negative 46. Signs are opposite, so we subtract, get the 22. 46 is bigger, so it's negative. On the bottom, I've got 1.5 times 10 to the 28. Now, 30 divided by 1.5 in my head, it's 20 for me. I don't know if you guys are that good at dividing decimals. I could just easily make this 15 here, because 30 divided by 15 is easy. If I make that 1 bigger, I have to make this 1 smaller. So think about that as a possibility. So 15 times 10 to the negative 29 is equivalent to 1.5 times 10 to the negative 28. So to get the final answer here, we divide these. 30 divided by 15 is 2. And And again, for the powers of 10, I recommend actually writing it on your paper so you can look at it. We're supposed to take the top power, which is negative 22, subtract the bottom power, negative 29. Okay, the rule says subtract. Your brain says subtract. Maybe you subtract, maybe you add, I don't know. The signs have to tell you what to do here. So top power minus bottom power, minus minus means plus plus. So if I'm looking at negative 22 plus 29, I do actually subtract. 29 is bigger, so it's positive. So we get a positive 7 out of that. Too many times I see people add those together instead of subtracting. I see them get a negative 7 instead of a positive 7. If you actually write the problem down here, minus minus changes to plus, you can very clearly look and see this addition problem subtracts, get you a positive result. Number 12, simplify 4 square root of 2/3 minus 7 square root of 3/2. So job 1 is to break this apart a little bit more. So 4 square root of 2/3 becomes that. Square root of 2 on top, square root of 3 on the bottom, 4 goes on the top with the square root of 2. Then I've got minus, I'm going to leave myself a little space here to fix this. Same deal here, 7 goes on top, the square root of 3 goes on top, the square root of 2 goes on the bottom. So that's priority 1, get the fractions separated. So we have just a nice friendly radical thing on top, which we don't care if it's radical on top. We have an ugly radical on the bottom we don't want. And the same deal for that one. In each case, you have to fix the radical on the bottom by multiplication of the same thing. So the square root of 3 times itself is what we're looking for. I'm required to multiply the top by the same thing. The red fractions only affecting the red fraction. The minus sign happens now. The green fraction, I'm going to multiply by the square root of 2 on the bottom and the square root of 2 on the top. Alright, so again, this is what I need to multiply by. I need to multiply the bottom, so I multiply the top by the same thing. So then, for each one of these fractions, I'm going to get a fixed fraction. So 4 is 4. Square root of 2 times the square root of 3 underneath the radical makes square root of 6. The square root of 3 times itself makes 3. And just like that, we have a friendly fraction with a nice, pretty integer denominator. Then we got our second fraction here. 7 is just 7. Square root of 3 times the square root of 2 underneath the radical makes square root of 6. Square root of 2 times itself makes 2. Just like that, we got a second fraction. We're not done yet because these both have square roots of 6. We are subtracting. We're supposed to actually subtract them. We do need a common denominator here, which would of course be 6. So looking at 3 and 2, 6 is the least common denominator. This needs a times 2, so the top does also. This needs a times 3, so the top does also. So what I end up with is a denominator of 6. For the red piece, 2 times 4 makes 8 times the square root of 6. For the green piece, negative 3 times 7 makes negative 21 times the square root of 6. So my final result now that I've got the common denominator created, I'm subtracting the tops, both containing square root of 6. 8 minus 21 tells me to subtract. 21 is bigger, so it's negative, and all that goes over 6. These don't reduce because this is inside, that's outside the radical. The only reduction possibilities happen here, but of course 13 doesn't divide by 6, nor do they have any common factors, so you can't do anything beyond that. Number 13, the altitude of a circular cylinder is 10 centimeters. So if we start with this, altitude of a circular cylinder. So if I draw a circular cylinder, wasn't very good attempt there. That's better. All right, there's my circular cylinder. The altitude is another word for height. So the height is 10 centimeters. Three-dimensional there. So there's our circular cylinder. It tells me what the volume is. The volume of the cylinder is 160 pi cubic centimeters. And it asks what is the radius of the cylinder, which implies we don't know that information, so I'm going to draw a radius there and call it r. So if I was just doing a volume problem in general, if they gave me some circular cylinder looking like this and said find the volume of this thing, and I did everything I could possibly do to this thing, the base is a circle of radius r. What we know about volume is it's the area of the base, which is pi times the radius squared, and it's the height, which is 10, and we multiply those together. So if I multiply those together, I get 10 pi r squared is the volume of this cylinder that we, of course, don't know what the radius is. But just like that, I've created an expression that tells me what volume is. And I've got over here what volume equals. So what I'm going to do, if V is equal to 10 pi r squared and V is equal to 160 pi, I know if I substitute right there 10 pi r squared for V, that should still equal 160 pi. Just like that, I've got an equation, and this equation has exactly one variable, and to solve this equation, I simply divide both sides by 10 pi. R squared equals, pi divided by pi cancels, 160 divided by 10 is 16. R therefore equals plus or minus 4. Same deal as before, so R squared equals, so we're supposed to put plus minus, but radius is going to be a positive number. So the radius will be 4, unit of length is centimeters. Okay, so you should expect a similar type problem. Again, just do what you can do with B and H to create an expression to represent volume. Set that expression equal to the volume they give you, solve for R, and you're good to go. Number 14, we're adding fractions. Now, I see a factorable quadratic expression on the bottom of that one, so the very first thing I want to do before I start actually figuring out a common denominator is rewrite the problem 4 over x plus 5 over x plus 3 plus 6x over, and then obviously 2 times 3 makes this work, positive 6, positive 5, so x plus 2, x plus 3. Looking at the denominators, the pieces of the denominators that we have are x, x plus 3, and x plus 2. Okay? This is being multiplied by x plus 3, but looking at different things, x is one of the things we have, x plus 3 is another thing we have, and x plus 2 is the final thing we have. So when you're trying to find the least common denominator, you want to see what things are going into it. And then the highest power of each one counts. So first power, first power, first power. So the product of those three things is going to be my least common denominator. So if I'm looking at this thing, and I consider that x times x plus 2 times x plus 3 is my least common denominator. I picked the wrong color there. There we go. So x times x plus 2 times x plus 3 is the least common denominator. I need each of these numerators to change appropriately from each change on the bottom. So this is 4 to begin with right here. This x is right here, but all this stuff is missing. So x plus 2 and x plus 3 need to be multiplied by that 4. Then I got a plus 5. That's here. Okay, x plus 3 is on the bottom, so x and x plus 2 are both missing from that fraction. So again, look at the denominator that is there, look at the denominator that isn't, that's what's got to multiply by the top of that fraction. The last thing says plus 6x, so I put plus 6x. Okay, looking at the denominator, x plus 2 and x plus 3 are already there, x is missing, so times x goes there. Each case, for each fraction, what changed on the bottom, make the same change on top. Then we got to fix the top. I want the top completely simplified here, so next, I'm going to multiply this stuff out. This is a binomial times a binomial, so if I do quadratic, or I should say FOIL, I'm going to get x squared plus 5x plus 6. Another way of doing that same product, very easily, is we just went from here to here, and now we're here and we're going back to there. So it's pretty simple. It should be right there on your paper. All right? Then I've got 5x times x plus 2. That's just a distributive property, so I'm going to get 5x squared plus 10x, and then I got plus 6x squared. That's just a single thing times a single thing. Just multiply the x's. The 6 doesn't have anything happen to it. Then I got my x times x plus 2 and x plus 3 on the bottom. I'm fine leaving the bottom completely factored. I just want the top completely simplified. The last thing is I got a distributive property here again. I might do that right up on top of this. So 4x squared plus 20x plus 24, 4 times each object. And now if I combine like terms, for x squared I got 4x squared, 5x squared, 6x squared, all positive. For x I've got 20x and 10x, both positive. For numbers I just have plus 24, and all that goes over x times x plus 2 times x plus 3. I'm looking for an answer like that. If you get to here and just stop, I might give you half credit for at least doing that much right. But factor, I should say, completely simplify the top, multiply stuff out, multiply stuff through, get me to a final simplified top over a factored bottom from that problem. Okay, last problem, expand x to the negative 3 y over p times x cubed y over p minus x cubed p over y. This is outside, this is first thing inside, this is second thing inside, they're being subtracted. So if I create the same structure and I'm fix each term to the best of my ability, I don't want negative powers, I don't want multiple letters of the same type. So this one, the blue, x, y, and p are all different. That's good, but x is the negative power. So y stays on top, p stays on the bottom, x cubed moves on the bottom. So everything is good about blue term now. There's 1x, 1y, 1p, all powers are positive. First inside object, I got 1x, 1y, 1p, all the powers are positive, so those are all perfectly fine. So x cubed y over p out of that one. Then I got a minus sign. And then I got the green term. X cubed, p, and y are all one of each letter, and they're all positive powers, so that's also perfectly fine the way it is. So the only fix I had to do for this problem, again with the blue term, negative power, I fixed it. Once I do that fix, now it's just a multiplication. So I'm going to multiply this times this, and this times this. So the outside object times each inside object. And when I multiply, I don't care about reducing when I multiply. Multiply first, then I reduce the results of those things. So if I do y times x cubed y, I'm going to get x cubed y squared. Y times y makes y squared, x cubed is not affected by that. If I do p x cubed times p times p makes p squared, x cubed times nothing makes x cubed. Then I got a minus sign. Y times x cubed p, they're all different, so I get x cubed py. On the bottom, p times x cubed times y, they're all different, so I'm going to get px cubed y. And just like that, I've got two answers, two terms in my answer, that I then have to simplify as much as I possibly can. So the first term, I'm noticing that there's too many x's, so they cancel. Y squared and p squared, there's one of each of those, they're perfectly fine where they're at. Y squared belongs on top, p squared on the bottom. The second term, there's too many x's, too many p's, too many y's. The x's cancel, the p's cancel, the y's cancel. Okay, and a lot of you just circle that answer and you're done. Those who do that are going to be wrong. Okay? If everything cancels, remember there's always a 1 sitting there, and minus 1 matters. The fact that it happens on the study guide means it will probably happen on the test too. One of those terms will come out to 1. That 1 has to be written. If it's not, you'll get it wrong. So be careful that you don't forget that. Every single time you have a term, you have to have a term accounting for it. If everything cancels, you do have to put the 1. It is required.